one and all present here. So in this video, I'm going to discuss about the terminologies used in big data environment. So here are the main terminologies which are used in big data environment. The first one is in-memory analytics and in-database processing, massively parallel processing, parallel system, distributed system, and shared nothing architecture. So in-memory analytics, the data access from non-volatile storage such as hard disk is a very slow process. So one way to combat this challenge is to pre-process and store the data like cubes or aggregates, tables, queries, sets, etc. so that the CPU has to fetch a small set of records. But this requires thinking in advance. So this problem has been addressed using in-memory analytics. Here are the relevant data which is stored in the database for faster access, easy deployment, and for business insights. And this is the architecture of an in-memory computing, in which in traditional computing we will access the data from the app data or application code, and then the database will store the data, so which will be in the main memory. But in-memory computing, the data will be stored outside the computing, and then the application data and an application code will access the database of record, in which it has a persistent recovery and post pre-processing and backup of the data which has been stored. So here when we use an in-database processing, in-database processing is also called as in-database analytics. It works by fusing data warehouses with analytical systems. Typically the data from various enterprises OLTP systems after cleaning up, so it requires deduplication scrubbing. Through the process of ETL is stored in the enterprise data warehouse or data marts. So with in-database processing, the database program itself can run the computations, eliminating the need for export and thereby saving on time. So here there are symmetric multiprocessor system, so in which the main memory is connected to the bus, and then there will be a bus arbiter through which the bus is connected the cache and then the processors. So symmetric multiprocessor system in SMP, so there is a single common main memory that is shared by two or more identical processors. So the processors have full access to all IO devices and are controlled by a single operating system instance. So SMP here are tightly coupled multiprocessor systems, and each processor has its own high-speed memory called cache memory and are connected using a system bus. So these are the terminologies used in big data environment. So it is a massively parallel processing. So MPPs refers to the coordinated processing of programs by a number of processors working parallel. So the processors each have their own operating systems and dedicated memory. So they work on different parts of the program. So the massively parallel process communicate using some sort of messaging interface. So the next is the parallel and distributed system, which is a well-known big data environment. So here a parallel database system is a tightly coupled system. So the processor cooperate for query processing. The user is unaware of the parallelism. So the distributed database systems are known to be loosely coupled and are composed by an individual machines. So the final architecture is the shared nothing architecture. In shared nothing architecture, neither memory nor disk is shared among multiple processors. So the advantages of the shared nothing architecture is fault isolation. So it provides benefit of isolating fault. A fault in a single node is contained and confined. Scalability. The disk is shared resource. Different nodes will have to take turns to access the critical data. A distributed shared disk system, thus compromising on scalability. So the three most common type of architecture for multiprocessor high transaction rate system is shared memory, shared disk, and shared nothing. So shared memory, a common central memory is shared by multiple processors. Shared disk. Multiprocessors share a common collection of disk while having their own private memory. And shared nothing, if neither memory nor disk is shared among multiple processors. So this is the architecture diagram of a shared nothing architecture. So in which the first one is the shared RAM. So here the RAM, in which it is connected to the bus, and it is either connected to your CPU, and then the shared disk. So here there is a storage area network called SAN, and then it is connected to your LAN, and then after that random access memory and CPU is connected. In the shared nothing architecture, so there So there is no shared architecture here. So the disk, RAM and CPU is an individual architecture for each and every LAN which is connected to the system. Thank you.